Good day. I'm Robert Jones from Scottish Power Renewables, and today I'll be presenting the first training pill from Project ROMEO, specifying an integrated data processing platform for optimal O&M of offshore wind turbines. So first of all, we have to discuss what is an integrated data platform. Our assets, of course, in this case, the wind turbines, they produce data. We have to get this data to a more central point where we can do analysis. This starts by going through a pipeline where perhaps it gets first of all stored in a local server, then perhaps passed to a centralized data server, and then on to the cloud analytics platform where the real work can begin in terms of analytics. But then we also have to consider that possibly we can bypass that infrastructure by using more modern technologies like the IoT. And then, of course, this analytics then has to be pushed out in terms of data insights so that we have usable results to benefit our assets. So we know what we want in terms of an integrated data platform, but why? It starts with strategic drivers. So why do we need these strategic drivers? We're developing data problems that involves many stakeholders. We have engineering experts, data scientists, data engineers, analysts, SCADA engineers, and they all have an input to this data problem and how to solve it. Strategic drivers, they enable a more focused activity on very specific valuable failure modes. And with that, we can optimize the cost benefit of our analytics. And with that, we then have financial value, which then allows us to solve arguments going into the future about what data to use, cybersecurity issues, so on and so forth. So what were ROMEO's strategic drivers? For this, we had a top-down approach where we had a level of monitoring that we were trying to achieve that was both in detection, diagnostics, and prognostics. We knew the target systems that we wanted to apply this to, the wind turbine systems and the foundation systems specifically. And then within each of those, we have business problems and priorities that we had to explore and failure modes that we had to better manage in terms of the main bearing, our converters, and other subsystems. Then from that, we have the data that underpins the foundation of our data analytics. So with this, we can include the right stakeholders from the start. I mentioned a number of them before. We need to be able to translate this business problem into a data problem. We need to be able to have our SCADA engineers that will set out what data is available, first of all, what data can come from our wind turbine assets. We need to know, we have our data engineers that know how to extract that information and get it into our databases for use later. We then have our engineering experts and our data scientists that are able to translate this further into a data and engineering problem and to choose whether or not to use data science processes or engineering processes. And with that, assess the feasibility of whether this is possible. If we don't have the right data to begin with, and we don't have the volumes to begin with, then perhaps we can't do it and we wouldn't be able to deliver a meaningful solution. And then lastly, we have to be able to make the connection. And that takes every one of these stakeholders so that we can deliver a full pipeline all the way to our analysts who are going to be looking at our results. Next, we have to be able to reconcile the data with the business problem. We have to be able to follow a structured process to balance engineering the data domains. You will have arguments between your data scientists and your engineers who believe that different approaches should be taken for analyzing this business problem. We need to be able to go through these structured processes so we can review the data that's available, think about it in the engineering context, and then think of it as a data science problem. We can do this by conducting FMECA, a failure modes, effects, and criticality analysis, apply symptom analysis on top of that, looking at each of those failure modes and looking at the symptoms that occur when that failure occurs. And then we can select the variables and the most suitable features, whether it be for the physics-based models, whether it be for machine learning models, so that we can have a robust failure model definition and robust supporting data to go with that. The next step is to organize the data and make the connection. We have to be able to assess the cybersecurity. We need to know the value again, so that we can balance it against the risk of providing this data. If we are giving access to real-time controller data, and there's a connection to that controller, there's a risk to the cybersecurity that you could pass a message back there, and we need our IT experts and our SCADA engineers to be able to assess that risk based on the value that we're pointing out. We have to be able to build a strong data model. We need our data engineers and our data scientists to get together so that we know how we can map out all this data and underpin it with a data model that makes it easy to use, whether that be using IEC 61400-25 or whether it be using RDSPP, so that you know how you can query your data, access it, and make relationships very quickly. And then from that, and with that data model, we need to be able to design an architecture and a network that is capable to do that. We have to be able to build the databases, make them easily accessible, and we need to make sure that the data flows naturally into those systems and unimpeded. Then we have to build a system. We have to have the right people that can build this architecture, work within the cloud and the cloud platforms, so that we can then go on and produce the accessible data and the results for our analysts going forward. And that's where the real value is created at that point, when this system comes together and it's in its entirety. So in summary, we want to eliminate the wasted time, and we can do that by knowing what drives our data problems and knowing the value behind our data. We want to include the relevant stakeholders. This is simply not possible for a lone data scientist, for example, to manage. There's too many other experts that are required, like your SCADA engineers, like your IT specialists, like your data engineers. We need to be able to follow systematic approaches so that we can balance the engineering and the data problems to deliver the most effective results. We need the right people so we can build these systems. We need to have a clear idea of what we're trying to build and why we're trying to build it. And then lastly, we need to be able to produce those accessible results and measurable results so that we can achieve the cost savings that are required. Thank you. And for further questions, please visit our website, romeoproject.eu.